Hey guys, it's me, Julian. Today's video is a review of limiting and excess reactants.
So, hello everyone. Today we'll talk about excess and limiting reactants again. Here's a sample problem where we put 17 grams of granulated zinc into 1 1/4 liters of 1 1/4 molar hydrochloric acid. We'll need the balanced chemical reaction for this, so let's write that down. You need a 2 on the HCl. The first question is, what volume of gas will be produced? That's the hydrogen gas here. So let's start with the zinc. Presuming we react all of 17 grams of the zinc, there's 65.4 grams in 1 mole of zinc. And 1 mole of zinc that reacts gets you 1 mole of hydrogen gas. Finally, we'll need here the standard molar volume of hydrogen gas. All gases are 22.4 liter at STP. And we have to presume STP here. We don't have other information, so we'll go with that. Check that the units are working out. They do. Moles of hydrogen at the end, and we wind up with liters. So 5.82 liters of hydrogen gas would be produced if all that zinc were used up. Let's look at the hydrochloric acid now. 1 1/4 liters, 1 1/4 moles per liter. There's 2 moles of hydrochloric acid here for every 1 mole of H2 that's produced. And again, 22.4 liters at STP. If all the hydrochloric acid were to be used up after checking units, we see we would get 17.5 liters of hydrogen gas. So there's a few things to notice here. First, the smaller value is the yield. That tells you the zinc is limiting, the hydrochloric acid is in excess, and the 17.5 liters doesn't happen. Okay, that number never actually occurs. We don't expect to see that. The second part of the problem is to get the concentration of hydrochloric acid after the reaction is complete. So let's work out first how many moles of hydrochloric acid we had before the reaction started. 1 1/4 liters, 1 1/4 moles per liter, 1.56 moles. Now we'll calculate the number of moles of hydrochloric acid that are consumed. To do this, we'll start with the limiting reactant, which is zinc, 17 grams. We've seen this before, 65.4 grams per mole. Finally, the molar ratio between zinc and hydrochloric acid, which is 1 to 2, that tells you that 0.52 moles of hydrogen chloride is used up in the reaction. Initial minus consumed will be equal to excess. Subtracting here, 1.56 minus 0.52 gets you 1.04 moles of hydrogen chloride. That's left over at the end of the reaction. So, to get the concentration, remember the concentration is moles per liter, and just calculate like this, it turns out to be 0.832 molar after the reaction is done. Now there was a bonus question here, just as a reminder to you about pH. Remember the pH is the negative log of the hydride ion concentration. Hydrochloric acid is strong, so its concentration is the same as the hydride ion concentration. So we'll just get here, take the negative log of 1.25 molar before, which is negative 0.097. After the reaction, we had 0.832 molar, so we'll get the negative log of that, and wind up at negative or 0.079 for a pH. Not important to our course just now, but just a reminder about pH. Anyway, look, here's the summary of these excess reactants problems. First of all, determine the yield and the limiting reactant from whichever yields least product. Second, calculate how much of the excess reactant was present before the reaction began. That is, how much was there initially. Finally, calculate how much excess reactant was consumed by the reaction. So this is another stoichiometric calculation, how much was consumed. In order to do this, you'll have to start with the limiting reactant. So this is how to determine what was used up. We're calling that the consumed value here. And finally, subtract. Subtract how much was used from how much you had to start off with. So that's going to be initial minus consumed equal excess. You can remember this by the song, Ice, Ice, Baby. So there you go. It's a pretty decent review of excess reactants. They're not hard to deal with, but you do have to keep your wits about you and remember that whatever was used up has got to be subtracted from how much you started off with. That's it. See you soon, everyone. Do have a look at our next 2 videos for more on this topic, and stay tuned for our next lesson as we start our next unit, stoichiometry of gases.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe!